everyone, good morning, welcome to GATE Academy 2.0, myself Harishankar. So again, right, after 1 day gap, हमने फिर से आया है like a CHEM-O-PHILIA series, ठीक है? So today's topic, today's subject is fluid mechanics, ठीक है? Start करते हैं हम fluid mechanics में. So once again, congratulations to both of the winners of yesterday's Menti quiz, right? So I hope most of you enjoy the session. So once again, regarding CHEM-O-PHILIA series, it is going to continue, ठीक है? And 2 o'clock you are having CRE, 5 o'clock you are having IPC, and night you are having heat transfer. Daily sessions are there, right? So tomorrow in CHEM-O-PHILIA series, in my session, it will be thermodynamics. So let me announce that also. Next Menti quiz is on Thursday, ठीक है? उसके बाद next Menti quiz will be on Sunday, right? So these are the information. So we have taken more than 2 sessions for fluid mechanics. There was one based on pressure drop, right? So there was one based on pressure drop, and there was another based on again based on Hagen-Poiseuille equation. That is also done, ठीक है? And again students were asking, right? So students were asking when will be the third session of FM or fourth session of FM, right? So they want FM to continue, so no problem. So good morning Siddhan, how are you? Okay, fine. Okay, so I hope so far it is good. So let us see, right? So what are the topics? So again, today's EC topic, I have taken very simple topics for FM so far, ठीक है? Whatever हमने जो भी डिस्कस किया है, पहला टॉपिक था प्रेशर ड्रॉप. Same way, today also I have taken a very simple topic, right? Very simple topic, and we will see how it is related, why it is important for GATE, right? Why it is important for GATE. Maybe अभी आज मैंने जो भी डिस्कस करने वाला है, right? That particular topic may not be useful for you in fluid mechanics. मतलब fluid mechanics question में like they may not be useful. लेकिन heat transfer पे इसके ऊपर questions आया है. That is your hydraulic diameter or your equivalent diameter, right? उसके ऊपर heat transfer subject you can see, right? कोई फर्क नहीं पड़ता है क्योंकि heat transfer या FM same तो paper है, right? GATE is same for both of them, both of the subject, right? So it is no problem. So let us start, right? So I hope everything is fine. So we will be starting the topic hydraulic diameter. So first of all, everybody know, सबको पता है equation क्या है, right? How we are using that, everything is no. So the speciality of this series is we will discuss one concept and we will see some problem, right? So these are the pattern we normally follow, ठीक है? तो उससे ही start करते हैं. First of all, right? First of all, let us check hydraulic diameter, right? So I will write hydraulic diameter. That is, where are we using this hydraulic diameter, right? Where are we using this hydraulic diameter? First of all, we are not going to go in detail, ठीक है? Detail में जाने की जरूरत नहीं है, because only one concept and one problem, that is about CHEM-O-PHILIA series. In detail we will cover everything in fluid mechanics. Clear? So देखते हैं first of all. Now, in your calculation of Reynolds number for fluid mechanics, you have what is the equation? That is, normally we will be writing rho dV by mu normally, and this dV used in Reynolds number is what it should be, hydraulic diameter. So from there we are starting actually, ठीक है? From there we are starting actually. Why it is special? So always your hydraulic diameter is equal to, right? Hydraulic diameter is equal to 4 times hydraulic radius. इसके ऊपर questions आ सकता है, because everybody know what is the hydraulic diameter, लेकिन in the question sometimes वो पूछ सकता है what is hydraulic radius, right? So उसके ऊपर आंसर गलत हो सकता है क्योंकि डायमीटर भी दिया होगा क्वेश्चन पे और रेडियस भी दिया होगा. So sometimes you may feel like, okay, you remember the equation and you will tick the wrong one, ठीक है? So hydraulic diameter, radius, both formula, right? So it is related by 4 into RH. Clear? So normally people remember directly 4 into flow area by perimeter. This is the one we remember generally, ठीक है? So let us see. So this radius, right? Your hydraulic radius is equal to flow area by perimeter, right? So diameter will be what? 4 times of that particular value. So we can see your equation is 4 into, right? 4 into flow area divided by, in FM we will say wetted perimeter, in heat transfer we can say heated perimeter, don't worry. So we will say it is wetted perimeter. Clear? यही equation है, everybody know. So we will see some general our cross sections and we will find the your hydraulic diameter, right? EC cases हम पहले देखते हैं, right? Once again, as everybody asks, right? Every time यही question आता है मुझे, sir हमने fluid mechanics start नहीं किया है, I am a first year student, I am a second year student, I haven't started fluid mechanics yet. Still you can watch it because I am taking only basic thing, right? Only basic thing. So, but this will be important for the preparation for the gate. Okay? So let us see. First, pipes ले लो यार, right? So pipe. So pipes में क्या होता है, for example, right? Pipes, when you have pipe, right? You have a flow through a pipe, right? Flow through a pipe. We can say what will be the flow area for the pipe. So if you want to find it for pipe, dH, 4 into what will be the flow area for the pipe? Flow area for the pipe will be always the cross sectional area because pipe के अंदर से flow हो रहा है. For example, ये bottle देखना. This bottle is kind of a pipe, not a same diameter. ठीक है, I am imagining it as a same diameter pipe. Same diameter हो, different diameter हो, कोई problem नहीं. इधर से ही flow होगा ना. So what is the problem? So if there is a flow from this point to this point, through which area it is flowing? It is flowing through this cross-sectional area, right? So this is your cross-sectional area. Or ये glass देखना, this is our chai wala, right? Chai's cup, right? So teacup. So you can see in this particular cup, this will be what, right? Or this will be what? This will be the area for the cross section. That is, through this particular area you will be having flow. That is, when you have a pipe, flow will be through this particular area. Okay? So what will be this area? This area is pi r square, right? This area is pi r square, but we will be always saying what? In terms of diameter. Okay? So pi r square को आपको convert करना है diameter के हिसाब से. So what will be that flow area? It will be pi by 4 d square, where d is the diameter of the pipe. ठीक है? D is the diameter of the pipe. So I am writing first for pipes. है ना? First I am writing it for pipes. ठीक है? So let us check now. What will be the wetted perimeter? मतलब everybody know what is the perimeter. Perimeter is this one is the perimeter. No problem. Now we wanted to know which perimeter will be wet when you have a flow. Right? That is, when water is flowing through this particular pipe, this is the perimeter that is getting wet. So what is that perimeter value? Perimeter is what? You know, 2 pi into r or pi into d. So since we want in diameter, so divide it by pi into d. So क्या हो जाएगा? Pi pi cancel, 4 4 cancel, d d cancel. So your answer for hydraulic diameter will be diameter. ठीक है? So hydraulic diameter for case of pipe or tube will be its diameter. Clear? So this is the point, first point. Clear? Yes. I hope this part is done. So let me see the comments. So Krishna has just messaged. Thank you, sir, for the gift, my second mentee prize. So very congratulations, Krishna. So who won the first mentee quiz, Krishna has just send me a photo, right? So he's saying he got the gift. Congratulations, Krishna. So he was the winner actually in the first mentee quiz. So once again, so whoever has won last day, right? Unka bhi gift aa rahe honge, like we have couriered already. So these things, right? So next, so that was the message I was reading. No problem. Okay, so this is the equation. Up to this is fine. Next. Pipes ho gaya. So let us think about some other shapes. So for example, another shape I'm going to talk about is, you can say duct. This is a duct, or I want to draw a square duct. So this is a square duct. Square duct ka meaning kya hai? That is, this is your square duct. Pipe ke jagah pe you have a square duct. Duct, if you didn't understand, new students, so this is duct. So cross section, right? So cross sectional area. Right, your area of the fluid flow, right? So where we will be having area. For example, if it is a square duct, I'm saying this is A, this is A, this is A, this is A. So what will be the flow area? Flow area will be A square, right? So area will be A square, right? So area will be A square. So let us check, right? So let us check now which area you will be having the flow, right? Which area you will be having the flow. That is, we can say, through this particular area you will be having flow, right? I hope. Right, so whatever shaded region, this region will be the cross-sectional area for the duct. Right, this area will be the cross-sectional area for the duct. So what will be that area? A square. So what will be your equation for hydraulic diameter for the duct? It will be A square, that shaded region, divided by which perimeter will be wet, right? Which perimeter will be wet? When you have a flow through a duct, this one, right? So we can say this 4 perimeter. So we can say what, 1, 2, 3, 4, that is 4 times of A, wetted perimeter. So A cancel, 4 cancel, your hydraulic diameter ka value kya hoga? It will be A, one side of the duct in case of a square duct. Clear? So this will be the value. Same way, next case, right? What will be in case of rectangular duct? You can calculate it, right? Rectangular duct also you can calculate. There is a gate question is there, so with that I will solve, no problem. So important part is, right, important questions are from hydraulic diameter in which topic? There is one topic called annulus, right? Annulus से जो भी flow हो रहा है, right? That is, annulus कहाँ पे होता है, right? Where are you having this annulus? Annulus is there in the case of what, your heat exchanger. That is, you are having an inner pipe and outer pipe. So जो inner pipe और outer pipe के बीच में जो area है, through that area, that particular area of the flow is your annulus. So annulus flow के लिए your DH क्या होगा? That is, if you have a non-circular cross sections, there you need what? Hydraulic radius or hydraulic diameter. So let us see an annulus diagram. So this is one of the annulus diagram. I hope you understand what is annulus. ठीक है? So this is your annulus. That is, मैं यहाँ पे लिख लेता हूँ. For example, this is your inner pipe, right? This is your inner pipe and this is your outer pipe. Clear? This is your inner pipe and this is your outer pipe. So which is annulus, right? Which is annulus here? Annulus is, this is annulus, right? This is annulus. That is the region from here to here, right? So this particular region is your annulus, or this particular region is your annulus. है ना? यही region है annulus. Clear? So when you have a flow like that, for example, inner pipe से hot fluid का flow होगा sometimes, outer pipe से cold fluid. Direction may be counter current, cross current, doesn't matter, right? That is your parallel flow, counter flow, doesn't matter. What we are saying is, what will be the hydraulic diameter in case of an annulus, right? Hydraulic diameter in case of an annulus. Clear? So this is what we need to find. अगर उसको find करना है, क्योंकि inner pipe में आपको question ही नहीं होगा, क्योंकि inner pipe is a normal pipe. ठीक है? Inner pipe is a normal pipe and hydraulic diameter for the inner pipe will be what? D diameter. Inner diameter of inner pipe. So कोई problem ही नहीं होगा. लेकिन annulus के case में you have problems. Right? Annulus के case में you will be having problems. You have to find the non-circular cross section is given. So उसमें से आपको calculate करना पड़ेगा what is the hydraulic diameter. So let us check how will we calculate with the same example. So once again, those who are asking what is annulus, right? Those who are asking what is annulus. So just let me show you this. That is simple है यार, फिर से वही, right? वही हमारा example है. This is your outer pipe, for example. If I am putting one pen like this here, right? So you can see this is your inner pipe and this is your outer pipe. So when I keep like this, through this inner pipe, ये जो pen है ना, inner pipe. So ये pen के through there will be one flow will be there, and through this pipe in between these two area, right? ये जो pen और your bottle के बीच में जो area ना, that is the annulus. आप कैसे भी करके उसको समझ सकते हैं. Very simple है annulus समझना. Otherwise ये पेन लेना, आपके पास सेलो ग्रिपर पेन तो होगा ही, राइट? सो यू कैन सी द रिफिल एंड यू कैन सी द पेन. सो ये जो पेन होगा, राइट, ऑलवेज इमेजिन किसी भी टाइम पे आपको किसी को एक्सप्लेन करना है, टेक दिस पेन यार, पेन, दिस इज योर आउटर पाइप, दिस इज योर इनर पाइप. सो व्हेन आई पुट दिस, नाउ इट इज ए हीट एक्सचेंजर, राइट? नाउ इट इज अ डबल पाइप हीट एक्सचेंजर. ये हो गया आपका इनर पाइप, ये हो गया आपका आउटर पाइप. सो व्हेन आई पुट इन दिस इज एन एग्जांपल ऑफ डबल पाइप हीट एक्सचेंजर. सिंपल. सो इनर पाइप, आउटर पाइप, ये दोनों के बीच का जो एरिया ना, आप जस्ट पेन लेके देख लेना, ये जो बीच का जो एरिया है, दैट इज योर एनुलस, राइट? थ्रू दैट एनुलस यू विल बी हैविंग वन फ्लूइड फ्लो, राइट? इनसाइड दैट पर्टिकुलर पंप, राइट? हमारा जो पेन में जो इंक है ना, राइट, वेयर आर यू हैविंग द इंक? इंक इज इनसाइड द रिफिल, राइट? ये जो ब्लू कलर है उसके अंदर इंक है ना, सो दैट इंक इज व्हाट? योर हॉट फ्लूइड, right? If that ink is your hot fluid, from that hot fluid to outside cold fluid, You will be having heat transfer, na? So this is a heat exchanger. If you consider ink is a hot fluid, now it is a heat exchanger. Very simple to understand with this. Clear? So this is the way you need to study, right? So this is the way you need to understand the thing, so it will be very easy to understand. Clear? So I hope you understood heat exchanger, right? So now we will just see, right? Now we will just see what will be the flow area, right? What will be the flow area for the annulus? ठीक है? What will be the flow area for the annulus? So flow कहाँ पे होगा, right? Where you will be having flow in case of an annulus? हम बोल सकते हैं कहाँ पे flow होगा? Flow will be here, ना? Right? We can say here. Flow will be here, right? That is, you can see here. This will be the region of flow, or I can say this will be the region of flow. Clear? I hope it is visible, right? This will be the region of flow. So which diameters the annulus fluid will have contact? Annulus fluid कौन से diameter से contact में होगा? That is outer pipe का inner diameter, right? Outer pipes inner diameter and inner pipes outer diameter. Confusion है तो देख लेना यहाँ पे, simple है यार, like very simple to understand. You can see here, two diameters we have contact is, first diameter we have contact is this diameter. आप यहाँ पे देख सकते हैं, this diameter. What is this diameter? You can see here. This diameter is, right, this diameter is di. That is di, मैं लिख लेता हूँ यहाँ पे, di is, remember, it is the inner dia of outer pipe. Inner dia of outer pipe. क्योंकि outer dia of outer pipe के through हमें कुछ contact ही नहीं है, आप ये bottle ले देना. Fluid has no connection with the outer diameter of outer pipe. It is already out, na? ठीक है? So now you can see, so di is your inner dia of outer pipe. Now, inner dia of outer pipe is in contact with the annulus fluid. Now what will be this next? Next, let us see which is the second diameter which is in contact. We can see this diameter, right? That is this diameter. Which is that diameter? That is the outer dia of inner pipe. That is D naught will be your outer dia of inner pipe, right? D naught is your outer dia of inner pipe. Clear? Clear? So we want to find which area will be the flow area for annulus, right? Which area will be the flow area for annulus? So everybody know the equation. So let us see the equation first of all. What is the equation? That is your flow area or your hydraulic diameter equation is 4 into flow area. I am writing first pi by 4 into di square. So if I say pi by 4 into di square, right? If I say pi by 4 into di square, right? What I am doing actually, right? If I say pi by 4 into di square, actually I am covering this complete area, right? I have covered the entire area now, right? I have covered the entire area because it is, this area is what? This complete area of the circle, right? This complete area of the circle is now, right? This complete area is of the circle is what? Pi by 4 di square. We don't want that complete area, right? We don't want the complete area. So from this complete area, right? From this complete area, so how much you need to minus, right? How much you need to minus from the complete area? From this complete area, we need to minus this much area. That is this particular area I need to minus. Then the remaining area will be what? That will be the area available for what? Your annulus. So what I will be writing? Di square minus d naught square. So this will be what? This will be your area required for annulus flow or cross-sectional area available for your annulus. Flow area available for the annulus is done. Okay. Now what about wetted perimeter? When the water is flowing, right? When the water is flowing, you can say when water is flowing, this surface will also become wet, or in this surface also you will have friction. In this surface also you will have friction, or यहाँ पे भी friction होगा, यहाँ पे भी friction होगा, or on both these surfaces you are having, right, water, because water is flowing through that, right? So there will be, it will be wet. So we are saying both perimeter you have to consider. So it will be pi into di plus d naught, pi into di plus d naught. So easily simplify kar lo, d naught se sab cancel ho jayega. So your hydraulic diameter for the annulus will be equal to di minus d naught. Clear? Your hydraulic diameter of annulus will be always equal to di minus d naught. Clear? Di minus d naught, that is your diameter of inner diameter of outer pipe minus outer diameter of inner pipe. That is question mein jo bhi higher minus lower, right? You will get the answer easily. Clear? So this is the hydraulic diameter for pressure drop, or equivalent diameter for pressure drop. Clear? So this is the equation for equivalent diameter for pressure drop. So let me write it first. So equivalent diameter or hydraulic diameter, equivalent dia for pressure drop, equivalent dia for pressure drop is equal to, so I am saying equivalent dia for pressure drop is equal to 4 into, so I don't need to write the everything, but still 4 into flow area is pi by 4 di square minus d naught square divided by pi into di plus d naught. Now in your heat transfer subject, right, in your heat transfer subject there are questions to calculate equivalent diameter for heat transfer. ऐसे भी एक question है, right? You have seen this questions, right? In heat transfer there is a question like क्या होगा your equivalent diameter in case of a heat transfer process. ठीक है? Heat transfer में क्या होगा, that is a question, simple. So heat transfer में क्या होता है, right? In your heat transfer और मतलब in your heat exchanger यहाँ पे क्या difference होगा? Difference ये होगा, you can see here, very very simple, that is your outer surface of the heat exchanger will be always insulated. Because क्या reason होगा insulation का? Outer surface क्यों insulation हो रहा है? Because it is a heat exchanging instrument, ना? Heat exchanging device, right? Heat transfer और our heat exchanger किस लिए use होता है? Because हमें hot fluid से cold fluid heat transfer करना है, very simple. ठीक है? Hot fluid to cold fluid हमें heat transfer करना है, and we don't want the heat to go outside. ठीक है? We don't want the heat to go outside. If the heat is going out to the surrounding, so heat loss हो रहा है ना? So we don't want the heat to go outside. So what we will do? We will insulate the entire outside surface, right? That is, अगर आप ये bottle देख सकते हैं, so इसके जो outer surface है, it will be completely insulated. Insulation का meaning क्या है? We don't want heat to go outside. So surrounding के साथ कुछ भी heat transfer नहीं होगा. So the meaning is strictly whatever heat transfer is there in the inside the system, it will be between hot fluid and cold fluid only. Right? There will be only heat transfer between hot fluid and cold fluid. We cannot allow the heat to go outside. So इसलिए हम लोग ये completely insulate कर रहे हैं. When we are insulating it, right? When we are insulating it, what is the meaning? Your annulus, your heated perimeter, ठीक है? In your heat transfer, we will say heated perimeter. We will say only, you can see here, only this surface will be heated. That is, only your outer diameter of inner pipe will be heated, because ये जो surface होगा ना, that will not be heated because it is insulated. Clear? So we will have a change in the equation in case of heat transfer. That is, यही same equation होगा. Only change is dE will be equal to 4 into pi by 4 di square minus d naught square divided by, you have one change, that will be pi into only d naught will be there. That is, di will not be there. That is, inner diameter of outer pipe is not considered in case of dE. Clear? So this is the difference in equation. आपके heat transfer question paper में, मतलब you can see there are 2 or 3 questions are there in your heat transfer book. Right? Heat transfer previous year gate पे इसके ऊपर questions किया है. But this dE, we may not be using this in the Nusselt number calculation and all. लेकिन exam में अगर if they are asking find the equivalent diameter for heat transfer, आप ये use कर सकते हैं. Clear? So there are questions in previous year where they have asked, वो एक annulus दिया होगा आपको, right? They will give you an annulus and they will ask what is the equivalent diameter for pressure drop and heat transfer. So दोनों के लिए आप calculate कर सकते हैं. I hope it is fine. Clear? So this is the point. Right, so just complete the equations. Once we complete, we can go for what? Our problems. Right, so once this is done, we can go for the problems. Clear? So whatever heat transfer problems are there, right? So I hope Shabnam ma'am will be covering that. Clear? So she will be explaining again heat exchangers. So heat transfer is over in live app, YouTube, everything, right? So you all know everything. So once again, those who are watching it for the first time, so you can see there are two equations, right? There are two equations for this. Clear? So let us check questions. Right, so let us check some questions. Yes, if any doubt in that, you can ask, no problem. Yes, so there will be only one change in the equation, right? So you can see there is only one change in the equation, that is instead of pi into di plus d naught, you will be having a small change, right? Pi into di plus d naught, you will be having only outer diameter of inner pipe in the question, right? There will be only outer diameter of inner pipe. So let us check the question. So we have solved questions based on pressure drop is done, right? So the first question itself, it's a 2004 question. What is the equivalent diameter for flow through a rectangular duct of width B? Okay, it is width B, it is not band, okay? Width B and height H. So tell me the answers. What will be the equivalent diameter of flow through a rectangular duct? Rectangular duct diya hai question pe. So give me the answers. So I hope this is visible. Equivalent diameter for flow through a rectangular duct. क्या होगा? बताओ answers. Clear? So let us see what will be the value. Right, let us see what will be the value. It is, they are asking about rectangular duct. Width is B and height is H. So how can we draw a rectangular duct? Right, so what is the meaning of rectangular duct? Rectangular duct is like this. This is a rectangle. Now we can say rectangular duct means ऐसे होगा. Clear? So which will be your flow area, right? Which will be your flow area? Which will be your flow area? This will be the flow area, है ना? This is your flow area, this shaded region. So they are saying height is H, width is B. Then what will be the equivalent diameter? So how can we calculate? That is, you have the answer. That is 4 into, right? 4 into. What will be flow area? Flow area will be H into B. H into B. And what will be the wetted perimeter? H plus B, H plus B. So it will be 2 into H plus B. So what will be the answer? It will be 2 HB divided by H plus B. Clear? 2 into HB divided by H plus B. So hydraulic diameter, right? Hydraulic diameter in the case of rectangular duct is this. Okay? So that also you can see. Clear? And important part, if they were asking rectangular duct's hydraulic radius, no need of this 4. You will be getting HB by 2 into H plus B, right? HB divided by 2 into H plus B, right? That is option A will be the correct answer if they were asking equivalent diameter. In case of diameter, if they are asking radius. Clear? So that also you need to remember. So those both kinds of questions they can ask. Simple. So can we go to next question? So let us go to next question. This is a question. Two liquids P and Q, two liquids P and Q, two liquids P and Q having same viscosity, two liquids P and Q having same viscosity are flowing through a double pipe heat exchanger as shown in schematic. Two liquids P and Q having same viscosity are flowing through a double pipe heat exchanger as shown in schematic. ठीक है? Densities of P and Q are 1000 and 800 respectively. Average velocities of the liquid P and Q are given 1 and 2.5 respectively. Inner diameter of pipes are given 0.31 and 0.1. Inner diameter of pipes are given 0.31 and 0.1. Both pipes are 5 millimeter thick. Both pipes are 5 millimeter thick. The ratio of Reynolds number of pipe P to pipe Q. Find it. Ratio of Reynolds number for the pipe P to pipe Q. Same fluid is flowing, that is two liquids, but same viscosity fluid. So they want you to find Reynolds number of P to Reynolds number of Q. So density of P is 1000. Density of Q is 800. Velocity of P is 1. The velocity of Q is 2.5. What about the diameter of P and Q? Any answers? Reynolds number equation, rho dV by mu, rho dV by mu. Mu is same in both cases. Solve. So let us check now. I hope the equation is done. So let us write here itself. That is, you can see here. They are asking, right? They are asking. So let me write it here itself. Reynolds number P to Q. So viscosity is same. I want the ratio of rho dV divided by rho dV. But this is for pipe P. This is for pipe Q. है ना? कोई problem नहीं है. So what is the density of P? P is 1000, density is 800, right? So I can write here, right? That is Reynolds number of P divided by Reynolds number of Q. Density of P is 1000, this is 800. ठीक है? Now what about velocity? Velocity is 1 and 2.5. So here it is 1, here it is 2.5. Now what will be the hydraulic diameter, right? What will be the hydraulic diameter for both cases? यही check करना है. So you can see inner diameters are 0.31 and 0.1. So Q, pipe Q का inner diameter क्या होगा? It will be 0.1 meter. 0.1 meter. So I can say Q, it will be 0.1. Now what about P? Because P is an annulus, है ना? P is an annulus. Annulus के लिए हमें कैसे find करना पड़ेगा? हमें इस value find करना पड़ेगा first of all. ये क्या है? That is 0.31. ठीक है? So ये total, this total value is 0.31. इससे we need to minus the outer diameter of inner pipe, right, minus the outer diameter of inner pipe, because di is given 0.31. What will be the outer diameter of inner pipe? Outer diameter of inner pipe will be, यहाँ पे आप देख सकते हैं, that is 0.1 is inner diameter of inner pipe. You need to add whatever thickness is there, right? So जो भी thickness यहाँ पे दिया ना, both thicknesses दोनों side पे आपको add करना पड़ेगा. That is, यहाँ पे भी 5 mm thickness होगा, यहाँ पे भी 5 mm thickness होगा. Clear? That is 0.1 plus 5 mm here and 5 mm here. So 0.1 plus 10 mm will be your DO. That is your outer diameter of inner pipe. That is your outer diameter of inner pipe will be inner diameter of inner pipe plus 10 mm, because दोनों side पे 5 mm करके thickness है. So add this. So what will be this? This will be 0.11. Right? So 0.31 minus 0.11, you will be getting what? 0.2 will be your value of equivalent diameter for the pipe P will be 0.2 multiplied by 0.2, you will get the answer 1. Yes, Siddhant, correct. So which option will be correct? Option correct will be C. Is it fine? Right. So I hope everybody is getting the answers. Yes. So same way you are having 2 or 3 questions in GATE, right? Same topic, same in the same concept. You are having same questions. मतलब आपके heat transfer से भी there are questions. In heat transfer they have asked annulus के लिए equivalent diameter find कर लो, ठीक है? So annulus का equation हमने लिखा है, right? So just check that. उसके बाद pressure drop के लिए भी, right? Equation लिखा है. So there is a question in heat transfer. After this class you can go and check. That is, they will give you the value of annulus and they will ask you to find both heat transfer and pressure drop. So difference क्या होगा, right? What will be the difference? One, in the pressure drop you have to consider both the perimeter di and d naught, right? Pi into di into d naught. But in your heat transfer you need to consider only your outer diameter of inner pipe. Clear? So these are the thing. So that's about today's session. Now next session will be CRE, right? In the afternoon 2 o'clock. And again IPC will be there in the evening, and in the night you will be having heat transfer again. Clear? So tomorrow in your thermodynamics we will be discussing degrees of freedom. Tomorrow's CHEM-O-PHILIA lecture will be degrees of freedom. Okay, degrees of freedom. Clear? That's all. Okay, thank you very much. So I'm stopping it. Thank you all.